these videos, channel, it's dedicated to quantum gravity, and also first I give you an overview of quantum gravity, then we delve into the basics, not the basics like undergraduate basics and master level and PhD level basics of understanding quantum gravity. Well, I'm not gonna go to the high school math, so there's no time to do that, and it's gonna be cumbersome, boring, and trivial. You need to do that by yourself. And why quantum gravity? It's important. Why it's important is fascinating. It gives us a great description if we reach to a complete or almost complete theory of quantum gravity, and we can make a marriage and connection, understandable, reasonable connection between quantum mechanics and the general relativity of Albert Einstein, then it gives us a better understanding of universe. Thus, it's fascinating, and it incites us. It gives us incentive and motivation to engage our emotion and rationality and thinking in to have be a better person, and also to do science and adds to the prosperity of life. And yes, the les effets secondaires means the side effects are it's kind of maybe complicates the world that we are living in. Let's compare right now 2025 to 1998. Lots of things have changed. The most important thing is internet and cell phones. That has changed the daily lives of people. But what I want to say is we need to add philosophy. So this channel is the marriage between philosophy and science. And philosophy is not, I repeat again and again and again, it's not just reading, it's a part of it, but the major part of the philosophy is having a philosophy for life, thinking, criticizing, loving, mixing different ideas, creating, and reading also. But it's not just reading Immanuel Kant and Nietzsche. These are my notes, lecture notes, and it's just one of them is just an overview of quantum gravity. I can say it's an introduction to quantum gravity. You need to know the undergraduate level math. I'm not gonna describe to you what's the differential equation, which I was the father of my nickname in university back in undergraduate studies, which I got 20 full score, 20 out of 20 in differential equation. I loved the books of differential equations. I madly loved it, and they called me the father of, or the mother of, in a funny way, of differential equations. We need to have an understanding of differential equation, but I can get to the intuition, and it's not necessary just to delve into differential equations and do the math. So, introduction to quantum gravity. Quantum gravity aims two fundamental theories. First is quantum mechanics, and the second is general relativity. What's quantum mechanics is about? Shortly governs. It's a theory that governs particles and fields at microscopic scales. I don't know what's the intonation and stresses on this word. Microscopic. And general relativity describes gravity as a curvature of a space-time due to mass and energy. I'm not going to say what is a mass and energy. There's theory about it, and we can get into philosophy and level of creation too. One of the reason I'm adding philosophy to this course is just to use Socratic dialectic to define the words, and it enlarges the room and the space to understand, and also use imagination. As Albert Einstein said, I'm not getting to logical fallacy, but it's important to understand what he said. And it's not necessarily correct, but he said imagination is way important than knowledge. And we see right now the imagination is something that remains, despite the fact that regarding the fact that LLMs, large language models, and artificial intelligence is extremely knowledgeable, and human knowledge is not that useful compared to the knowledge of LLMs and AI. So the thing that remains is imagination, emotion, creativity, that we can compete still and give meaning to life with competition, comparing ourselves, not comparing, just like, look at ourselves regarding to LLMs and AI. What I want to say is, like, if, for example, in chess, game of chess, that Elon Musk says it's an easy game, it's totally wrong. We're using the mathematics and combinatorics. The amount of possibilities of playing a chess game is extremely large, and it's not infinite necessarily to the extent that I remember, but it's infinitely large. There are some limits to the rules of the game, and it needs lots of thinking and imagination to play a chess game. It's not an easy game in any sense, in any measure, based on any measure. But what I want to say is that the chess game in late 90s, Garry Kasparov, one of the geniuses in chess, he lost his first match to Deep Blue, an AI or supercomputer. And right now, Magnus Carlsen and all of the geniuses in chess, they get crushed by an AI computer easily. So the question is, as Fabrizio, I think his name is an American-Italian chess player whose ranking he's a grandmaster, and his ranking is second or third, I'm not sure, in the ranking of the grandmasters of chess. And he said, like, when you reach to the age of 30 in chess, you ask yourself, what are you doing with your life? Because if you take chess and playing chess, advanced chess, professional chess, out of life, out of earth, nothing happens. It's not a big... Playing a little bit of chess gives you insight and perspective to live your life and see the different perspectives of a thing when you're doing it in life, and making decisions. Like, just don't be impulsive and not being impulsive, and seeing the different perspectives of the life. But high level chess, reading 10 layers of thinking and moves, what's the point of that? It's a great question. So the question that remains is, like, when you're replaceable by AI, what you need to do? Just stop doing it. Because chess is it's not an emotional game necessarily. It's a rational game. It's logical, and binary, not binary, just like, it's digital. It's like a digital. It's like there are pieces, and you choose, and there's no emotion involved necessarily. You have characters like the American guy, and also Garry Kasparov, and I forgot his name. He had misogynistic views about women. It was the chess grandmaster, American chess grandmaster back in 1970s. I forgot his name. Jesus. I don't remember his name. There's too many things in my mind. And then he changed his mind, and he stopped his misogynistic views, and he said, like, women are great in chess too, this kind of things. And he won against the USSR, against Boris Spassky, if I'm not. This comes to my mind later. Okay, so we need to do something in science that's not replaceable easily by LLMs and AI. So general relativity describes gravity as a curvature of space-time due to mass and energy, and I'm going to define what the field or quantum field is later. Since gravity affects everything, including quantum particles, a complete physical theory must incorporate both quantum mechanics, and also both quantum mechanics and general relativity and quantum mechanics. However, their mathematical structures are fundamentally different, leading to deep conflicts. We're going to get to the mathematics of quantum mechanics. Well, for example, harmonic oscillators, Schrödinger equations, this kind of things, using a Griffiths book or other book, in a very fast and intuitive manner, and with, like, I'm gonna just show you what it is about, and then you need to go and read it for yourself to some extent. And general relativity as well. The intuition of general relativity and imagination of that is beautiful, it's amazing, but the math needs some work. Why do we need quantum gravity? Quantum mechanics is stuck in my head. What's the name of that chess player was? Jesus. I don't remember. Quantum mechanics describes forces with quantized fields, such as electromagnetic force via photons, using Hilbert spaces and wave functions. What's a Hilbert space? You need to know some algebra, some group theory, some, what's the space in algebra, what's the space in mathematics? What is a Hilbert space? It's big, it's small, and what is big and small? So probabilistic nature via Schrödinger equation. This is Schrödinger equation. I'm just not gonna tell you exactly what does it do, because I get a little bit obsessed to talk about it for hours. How do we drive it? How do we get to it? Like blah 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 blah. Psi. You need to know what's linear algebra, what's a normal operator, what's a Hermitian operator, what is this, which is a matrix. This is a vector, which is called psi. It's a quantum state of an isolated quantum state, like a very small particle, 10 to the minus 10 meters, something like that. And this is the constant, it comes from nature, and this is the I, complex number, and this is the first degree differential equation. And when you solve it, you get psi based on t, and it shows you through the time how a quantum state changes or evolves in some manner. Describes gravity as a space-time curvature, not a force in the Newtonian sense, governed by Einstein's field equations. I'm gonna write. Jesus. Okay. This is Einstein's field equation. Let me write it in a beautiful way. It's minus. Wait. Rookie mistake. G U V plus G U V equal to 8 pi G C speed of light for T U V. It's not a very sexy equation, but it's it seems linear and it's important. And we need to understand that what's a field equation and what's a general relativity field equation. We're going to talk about it at least in an intuitive manner. So the key problem: gravity resists quantization. What is quantization? Think about it. It's just very simple, and I'm not gonna. It's in my mind. If I don't describe, someone can accuse me. Oh, he doesn't know. I'm not gonna waste my time. Get to the atoms of logic and intuition behind it. It's just a waste of time, man. Have you ever attended a course in fundamentals of quantum mechanics, maybe by Paolo Zanardi? He jumps. He rarely teaches anything. Sorry, Mr. Paolo. You blocked me on Facebook. And I attended 5 or 4 of your courses: quantum information science, fundamentals of quantum mechanics, quantum field theory, I think, and the quantum fundamentals of quantum mechanics 2, quantum mechanics 1, quantum mechanics 2. And I was interested about quantum information science and also black holes since 2014 that I passed the course with A-. That's good. In quantum information theory, a book by Mark Wilde. He's in Cornell right now. I met him in Berkeley. Yeah, he was very nice. He talked to me, despite the fact that so many people were resisting to talk to someone which was a master's student at the time. Because if you have a doctorate, you're not that important. According to the incarnation of the word logical fallacy, appeal to authority in the character of so many academics in the world. I hope you understand. If you don't understand, it's your problem. I was extremely clear. So think, motherfuckers. The key problem: gravity, resistance, and other force electromagnetic is described in quantum field theory. However, quantizing gravity leads to infinities that can't be removed by renormalization. What is renormalization? We're gonna get it. In quantum mechanics, time is absolute. What does it mean? We're gonna get to it. But in general relativity, time is part of dynamic space-time structure. There's like 1 billion clips talking about this general relativity in an intuitive manner, with like, graphics and sexy and these kind of things. This contradiction means our current mathematical tools are insufficient. Approaches to quantum gravity. Canonical quantization. What quantization, like quantifying, and what is canonical? Wheeler-DeWitt equation. What was the name of professor at MIT? He started with history and then he got into quantum, and Edward Witten. Yeah, he was genius. He has, 1 billion citation. And one naive approach is to what was the relation with this? Because DeWitt is kind of reminded me of Edward Witten. Maybe it's the same thing, I don't know. Same person. One naive approach is to quantize Einstein's equations in analogy of quantum mechanics, which is... This is very funny. Like, what? This is H, okay, this is matrix, but this is a vector, and the prefix is universe. Like, how much cocky you can get, for God's sake. Anyway. Loop quantum gravity. Instead of treating gravity as a force, LQG describes the spacetime as discrete and quantizes the Planck scale 10 to the 19 minus 35. It replaces the smooth geometry of general relativity with a network of loops called the spin network. What is the spin network? We're going to get to it. Leading to discrete spacetime volumes. String theory. Oh, no. Thanks. String theory of everything. First of all, theory of everything doesn't exist, bitch. And you can't say everything. Everything is not even imaginable. Everything in a limited manner, yeah. But even that, using Socratic dialectic, if you get to the level of atomic scale, you're going to say, what is everything? Proposes that elementary particles are vibrating in strings rather than points like. Gravity emerges naturally, that's beautiful, as a quantum force meditated by the massless spin 2 particle, graviton. Requires extra dimensions beyond the space-time. 4? I don't understand what they write here. Beyond the field of the space-time, like, for example, 10 or 11 dimensions in superstring theory. 3 dimensions is not that easy to imagine. Then 4 is kind of wow. I don't understand, like, 11, 10 is crazy. Holography and ADS-CFT. Holographic principle. Information inside the volume of space can be encoded on its boundary. Wow! The first word that comes into my mind is black hole. ADS-CFT duality, a deep link between a gravity theory and a higher dimensional space, anti-de Sitter, and a conformal quantum field theory and its boundary. Experimental tests and challenges. Unlike other quantum theories, testing quantum gravity is hard because the Planck scale 10 to the minus GeV, 10 to the 19 GeV is far beyond current experimental reach. However, possible tests include Hawking radiation. Mr. Hawking, rest in peace. Quantum mechanics predicts black holes emit radiation, leading to the famous black hole information paradox. What is information? Changing of entropy. What, according to Seth Floyd from MIT in one of his lectures, what is entropy and why? What's the relation between information and changing of entropy? Why we define information in this way, and what are the other definitions of information? What is quantum information? And what happens to information, classical and quantum information? In black hole, what is a black hole? In a simple way, Chandrasekhar limits, like, which related to the volume of a black hole, a piece, and also the mass of it, which gets like so dense, it creates a gravity, then light cannot escape. What I was talking about? Information. What is the relation between classical information and quantum information? How do we relate that? Like in the Socratic dialectic way, or just like manner, or like in a deep levels, what's the relation between quantum information and classical information? I don't know, we don't know, human doesn't know, still, it's not an answer. You need to guess. Always. As the weird Woody Allen said, a mental masturbator in philosophy pretends he knows he cares about philosophy, but he really doesn't. And a fan of Anton Chekhov. Anton Chekhov was an idiot because he said that crying is a sign of mental disease or illness or instability. And also, what else he said? He said poets are useless. He can kiss my ass, Anton Chekhov. And Woody Allen said, 90% of life is showing up. So what I mean, you need to show up. You need to, if you don't know, you need to guess. Gravitationally induced quantum entanglement. If gravity can entangle quantum particles, it must have quantum nature. So next, we're going to get to, this is the end, solution to quantum gravity. Not the complete solution. This was something that we came up, not we, but in this case, we means I, me. And QG must unify space-time curvature from general relativity with quantized fields. Gravity is an emergent quantum effect. That's the idea. And the approach is going to be space-time emerges from entanglement. Curvature is linked to quantum information gradients. Einstein equations arises thermodynamically. A quantum curvature equation replaces classical geometry. This framework provides a quantum first perspective on gravity that avoids infinities while preserving classical general relativity at macroscopic scales. And I was attending a course by a German guy in the USC, and it was a course of thermodynamics. He spent 30 minutes to say that it's been 200 years or 107 something years that the thermodynamics has not been changed. It's very doubtful, it's very unlikely that these laws gonna change or get ameliorated or like changed in any sense or form way. He was implying that they are carved in the stone, the rules of thermodynamics. I doubt that. We will see about it.